Hello. In Investigation 5, we're going to continue our work from Investigation 4. If you recall, students looked at sedimentary processes, and the investigation culminated with students creating models of layers of sandstone and followed by a layer of shale. Investigation 5 picks up right where we ended with students looking at limestone and the processes that lead to the formation of limestone. It comes in four parts and takes about a week to complete. And students begin by looking at some of the chemistry of limestone formation. This is calcium hydroxide, which comes with the kit. Students will not be working with this directly, but instead you as the teacher will be using this to create a saturated solution of calcium hydroxide, which is also known as lime water. Follow the directions of the kit very carefully. Basically, it asks you to pour in a certain amount of water, add a certain amount of the calcium hydroxide powder, and you want to make sure that when you mix that and you put it in the bottles as instructed, that you leave as little or no airspace as possible at the top of the bottle before you put the cap on it. The reason is that the lime water or the calcium hydroxide will react with any carbon dioxide in the air to produce the calcite or calcium carbonate precipitate. So once you make this solution, if you're going to keep it for a couple of days as instructed, you don't want it to come in contact with the air. So it's best to have it in the bottles with no airspace at all. What's going to happen is when you're ready, and I recommend what I find very useful is to have individual smaller bottles, one for each class, so that way I don't have to open it until I'm ready. You're going to pour out and measure the amount of the lime water that you need for each student and transfer that gently into their reaction cups. They come with a lid that has has a hole in it for a straw, because what the students are going to be doing is they're going to be blowing bubbles into this reaction chamber with lime water. I don't know if you can see it in this photograph, but there is a little notch that I cut out of each of the straws, and that's as directed in the instructions in the teacher's guide. The purpose of that is that the students can blow into the straw, producing bubbles and introducing their carbon dioxide into the lime water, but they cannot generate enough force to suck up the lime water and accidentally ingest any of it. So that's a safety measure. When they introduce the CO2 into the lime water, immediately it reacts with calcium hydroxide and produces the calcite or the calcium carbonate precipitate that makes it look very cloudy and milky. You'll then let that sit for a while. It'll form a very clear layer at the bottom of precipitate. You'll decant the excess water off and then let that dry for a day or so. Students will later come back, test that with hydrochloric acid to confirm that what they in fact did make is calcite or calcium carbonate. A little safety note, the teacher's guide makes it clear that the lime water that you've made is fairly safe. It's not very dangerous and not very strong. However, because we are working with chemicals, I tend to, since I have a set of eye protection in my classroom, I tend to have the students use the eye protection anyway, simply because I want them to have a respect for lab safety whenever we're using any kind of chemicals that might result in any kind of splashing. So even though I know it's safe for the students, I do have them wear the eye protection. A little side note about content. Limestone, this is a quote I just found from Encyclopedia of Earth, and you can see the website here. I won't read it word for word, but basically limestone there can be biological limestone, which is the vast majority of limestone, and that's formed when marine organisms with calcareous shells, such as corals and forams, get deposited into sediment and get incorporated into the sediment forming limestone. And but you can also have limestone that's formed chemically through the precipitation of calcite that's dissolved in seawater. In the teacher's guide, there's a script you're supposed to read to the students when you're debriefing the lab that they just completed. And as you can see here, I won't read it word for word, but it basically states that some animals use calcium for their shells and bones and so on, and that those materials can get incorporated into the forming rocks, and that is the source of the calcite that's in the limestone. So far, so good. Where I have a problem is this second part, where you're asked to tell the students the following, and I'll read it. The other way calcium carbonate forms is when CO2, exhaled by organisms living in the sea, reacts with calcium in the water. In this case, the calcium carbonate forms right in the water and precipitates to the bottom. We saw that happen in our cups. Frankly, this is bogus. It is factually incorrect, and I think that the reason why Foss has us give students this story is because it is parallel to what the students were doing with the cups. However, it contradicts what the teacher's guide actually gives us teachers in the background information section, which I show here on the left. You can pause it and read it if you want, but basically at the top, you can see the chemical reaction for the formation of calcite in seawater. And in the teacher's guide, it clearly states the calcium ions are produced from the chemical weathering of rocks, and that enters into the ocean. And that the bicarbonate ions form when carbon dioxide from the atmosphere combines with water to form carbonic acid, that then ionizes to form hydrogen ions and bicarbonate ions, which you see here. And that is what reacts with the calcium to form calcium carbonate. So I omit this part entirely because I feel it's disingenuous to tell students this story about fishes respiring in the water and that makes limestone. And instead, I just tell them kind of a watered down version of this, talk about a little bit about the chemistry. I do show them the reaction, and but I don't hold them responsible for it. My purpose of showing them the reaction is because I know in 8th grade, the following year, they are going to be doing chemical reactions, and I just want them to become a little bit more familiar with some of the uses of these letters and numbers as they see them at this point in time. But again, in my opinion, I would omit this part right here because it really is not correct. The investigation ends with students going back to their basins where they put their model of sandstone, their model of shale, and they're producing a model of limestone on top. I'm very clear with the students that these are models of the 3 different types of sedimentary rock, that they're not actually producing real sandstone, shale, or limestone. But this is important. This is an important activity because by the end of this, they will now have these 3 horizontal layers, and it allows you to get to the 2 key ideas that you want the students to walk away with, and that is the principle of original horizontality, which states that sedimentary layers are deposited in horizontal orientation initially and form the rocks, and that if we see them in anything other than a horizontal orientation, then something must have happened to change that. And secondly, that the principle of superposition states that new layers are always deposited on top of older layers. And so therefore we can get the relative ages of the rock layers by following that concept. So that about ends investigation 5. It's fairly straightforward, and it wraps up the sedimentary processes explored in the Foss Earth History Kit. Good luck.